Alright, so this is Unit 1.1, this is Video A, and we're going to be talking about simplifying algebraic expressions and using our order of operations to do so. So we're going to kind of go through some of the vocabulary terms that would be associated with that and some of the basic steps for simplifying expressions. So just a few things that we need to highlight. So we have three vocabulary terms that we're going to be focusing on today. And the first one is algebraic expressions. And as you can see, an algebraic expression is basically anything else that we might run into in a math basis that contains operations, numbers, and or variables. But most importantly, it's the variable part. Expressions, one of the things that we need to be understanding is it's not equal to anything. So really, whenever we use expressions instead of equations, is that we're not trying to compare it to a number. We're just trying to use it to express a particular value or something else like that. Yes, it'll have an answer, but it's not equal to anything as a comparison. The next thing is a term. Now, a term is a piece of an expression, and it's separated by what we know as the addition and the subtraction. So anytime that you see addition and subtraction, it separates terms. So one of those examples, if I was to give you 2a plus 3b, 2a is a term and 3b is a term. So they're separated by addition, and so they're kind of different pieces of our expression. Now the coefficient is just the number being multiplied in front of the variable. It just kind of gives us that modifier of telling us how much of something that we have or how many multiples of something that we have. So when we look at the example that I just gave you, let's say 2a plus 3b, the 2 and the 3 here would be considered the coefficients. Those are the things that we're typically going to be working with. The variables are just kind of byproducts, and they're basically just along for the ride. Now, a couple of things that you probably already remember are your order of operations. And so as we go through these, we're going to kind of list those so that we have those at least down written so that you're aware of those. So the first one would be our parentheses. Or in some instances our other grouping symbols. So what we're familiar with is we might be familiar with brackets. Those would sometimes count too as well. We'll get into this a little bit later, but square roots act as grouping symbols. Basically anything that might have something to do with its own or anything else like that would be something that we would need to do. The next one that we have would be exponents. So anytime that we see exponents, that's something that we need to take care of. Sometimes we have roots, which would be also considered our square roots. But anytime that you see a set of parentheses and exponents, it's kind of one of those things that we would make sure that we do the parentheses first and then the exponents. But in some instances, we'll see that we can kind of do some of those simultaneously. The next ones that we should be familiar with would be our multiplication and division. And we might see this in different ways. We might see this as fractions and things like that. So those would be considered multiplication and division. And just be aware that those don't have to be done one after the other. They can kind of be done in order as long as it's kind of all at that same step. But division can come before multiplication, and multiplication can come before division. But we just need to make sure that we're doing that left to right. And the same thing with addition and subtraction. They can be interchanged, but you just need to make sure that when you're doing these, you're just kind of doing them in order from left to right, and kind of whichever one comes first is the one that we're doing. So there's our order of operations. Those are some things that you should be familiar with as we move on with some of the simplification. Now, what we need to at least explore is the idea of what it means to be simplified. And expressions, no matter what they are simplified if a couple of things come together. There are no operations to perform. So when we're talking about our operations, we know we have multiplication, division, addition, subtraction, parentheses, and everything else like that. So as long as there's no operations to perform, something is considered simplified. For example here, if we look at this, we have 2 parentheses m minus 3n. Now most of you should be familiar with by using the distributive property. And our distributive property tells us that when we see a number outside of parentheses, we apply it to all the terms. So that's a term and that's a term. And so we can multiply that, and it would be 2m minus 6n. And so by something like that, that is considered an operation. And then once we do that, then it would be considered simplified, unless The next part is we have all like terms are combined. So as long as we're not repeating any kind of terms, or we're not repeating any kind of variables, then we would consider something simplified. So when we look at here, 3m and 2n, those are completely different pieces, and so those are not like terms, and we would consider this to be simplified. So if you remember from some of the things that we've been doing, or that you have done before, we need to look at simplifying expressions. Now, I have a couple of steps that I go through to make sure that we appropriately go through and recognize like terms and things like that. So step one that I would go through is to do the following. Would be to check for parentheses and exponents that would be associated with parentheses. As you see here, we do have exponents, but those are kind of applied to variables, and those don't really count. But we're looking for operations that we can perform. And so the idea is that when I'm looking at this, I'm looking for things that I can kind of cancel away, if I could potentially do that, things that I need to distribute, those kind of things. And as it looks as if right now we don't have those things, we just have basic addition and subtraction, because what we have is we have a term minus another term minus another term and then adding another term. So when we look at this, we don't have anything else that we need to multiply or anything else like that. We've just basically got down to our addition and subtraction. And then our next step would be to identify any like terms that we have. Now, I do something very specific when I do this. What I like to do is I like to put boxes and different shapes around things that are like terms so I can easily identify them. And so I basically just go from left to right and I go down the list until I get all of the terms of my expression taken care of. And so the first thing that I'm going to do is I'm going to put a box around 5z squared, and then I'm going to look for anything that has that same variable exponent combination, and that's what makes like terms. And so when we think about like terms, it's the exact same thing. The numbers, they don't matter. It's only the variables. And so I have 10z, that's not the same, and then I have minus 8z squared. Notice what I did is I actually incorporated that subtraction with that, and that's going to help you down the road. And so if you incorporate subtraction with the term that's right after it, this will make it so that it's more of like a net. You're working with negatives rather than with subtraction. Okay? And I have no other z squared, so I'm going to start back at the beginning with the things that I haven't taken care of yet. So I have this minus 10z, and then so the idea is this minus 10z. I have plus z over here, and those are considered like terms. And so my second step was just basically identifying those so that it's a little bit easier to manipulate. And so my last step would be to combine like terms. So I basically take the ones that are the same. I have 5z and negative 8z squared. Now when we're combining like terms, variables don't change. Those are basically just kind of there along for the ride. The only thing that we change are the numbers. And so we have 5 minus 8, and so that would give us negative 3. So my first term is negative 3z to the second. And then I have minus 10 plus 1z. Remember, we always have that hidden 1 in front of those variables, and so that would give me that would give me negative 9z, because negative 10 plus 1 is negative 9. And so that's just kind of the basic overall thought process when we're trying to simplify expressions. And so we can continue that here. So we're going to look for like terms. And again, remember, when we talk about like terms, we're looking at the same variable an exponent combination. So it might be in a different order, so we just have to make sure that the variables have a specific exponent with them and a variable and everything else like that, and that would be considered a like term. So that when we go ahead and do this, when we look at our different terms, I start with the beginning. So we have 14x to the 8th y, so we need that exact same thing. And so I go through my list here, and actually I don't have any like terms. Yes, I see an x to the 8th, but it doesn't also have a y with it, so I can't use that. I go to the next one. I'm going to go ahead and circle this one. We have x, y to the 8th. And then in this case, that one is not the same, but this one, whoops, almost forgot to add that operation in there, plus 14xy to the 8th. Those are exactly the same. And then the last one that I have, I'm going to double underline, and that's really the only one. So I have 3 different terms that are associated with this one. So now that I've identified those, I can go ahead and I can start to simplify. So the first one, 14x to the 8th y, would be the first combination. Negative 14xy to the 8th plus 14xy to the 8th, that's basically negative 14 plus 14, and so I'm going to write plus 0xy to the 8th to show that those basically are going to add to 0. And then I write my last one, because it doesn't have any pairs, to 14x to the 8th. Now what happens, obviously I do not have to write that one because it is 0, but that's the only time that variables go away or a term goes away, is that when they add to 0. We don't subtract things or we don't add things to make the variables go away. The variables will always stay around. The only time they disappear is if the coefficients add up to 0. And so there is our final simplified answer. Alright, so this one here is, again, we go back to our first steps. Our tip here is to perform operations. And so the first thing that we're going to do here is we're going to distribute. Now this one might look a little strange, but the idea is that this subtraction is going to be associated with all of this set of parentheses. And so basically what we're going to do here is we're going to take this negative, and we have that imaginary 1 there. We're going to distribute that to everything. And so we have 3xy squared plus 8x minus 2xy squared minus 12. And so there, when we look at performing operations, that's really what we're trying to do. We're trying to simplify everything a little bit more so that we can just work with like terms. Now when we work with our like terms, so we're going to identify those. So we're going to identify like terms. Now when we identify like terms, remember the only thing that we have to look at is the variables. Don't worry about anything else. The variables have the only bearing on like terms. The numbers don't even matter. So when we look at this, we have 3xy squared, and then we have a negative 2xy squared. Those are the like terms. We have this 8x, which kind of stands alone, and then we have our negative 12 that also stands alone. And so what we would then do is then we're just going to combine. So our third step is combine like terms. So let's go ahead and do that. So 3xy squared minus 2xy squared. Again, when we combine, yes, it's the variables that tell us what are like terms, but we actually only use the numbers to do the operation. So 3 minus 2 is 1xy squared. The 8x didn't have a partner, so we're just going to write plus 8x and then minus 12. And so there is our simplified answer. So the variables tell us the like terms, but we only do operations with numbers. We don't even have to worry about the variables once we identify them. Okay, so the last one is we're going to look at advanced simplification. Now, when you look at this, you might start to freak out just a little bit and say, okay, man, now there's a fraction there, then I have no idea what to do with fractions. I've always hated fractions. But here is a quick tip for you to kind of get through that. So you're basically just going to leave the fraction alone until you actually have to use it. So when we go through this, the first thing that we're going to do anytime we see a set of parentheses is probably try to distribute. So we're going to distribute this negative 2. And so I'm just going to rewrite. So x squared over 3 plus 4x squared minus 2xy squared minus 2x squared y. Now I'm going to identify my like terms. And again, remember, it's only the variable that identifies like terms. So we only have to look at the variables. Don't even worry about the numbers. Don't even worry about the fraction. And so we have an x squared, and we have a 4x squared, and then we have a xy squared, and we have an x squared y, which I'm going to double underline that because those are not the same. The x is only by itself, and then the y has a squared, but in the other one the x has the square, not the y. So those are not the same. So really the only two things that I have to focus on are this x squared over 3 and a 4x squared. Now one easy thing that you can do with this, if you remember adding fractions at all throughout your elementary, this is 1/3 x squared, and this is plus 4x squared. Now, what I told you on the previous page is that we only have to worry about the numbers. So once I've identified these like terms, really all I'm working with is 1/3 plus 4, and I can just kind of write that a little bit different. If you remember what we do with this, we can make this a fraction. So write it over 1, and so we have 4 over 1 plus 1/3. We can make these the same or equivalent fractions, and we can times this by 3, times this by 3. And so that turns into 1/3 plus 12 over 3, which then in turn turns to 13 over 3, and then we can just add our variable to that. So when we look at our simplified answer, I'll put that in this section right here, would be 13 over 3x squared, and then we have just the rest of it written because that's the only thing that we have to worry about. So when we look at these, it's important to remember like terms, what identifies like terms, what creates like terms, and everything else that goes along with it. So just make sure that when we're doing this, you use the variables to identify them, but you only work with the numbers. And that's going to do it for this video.